Okay, hi everybody. Today we're going to move along and cover a definite integral that has an absolute value associated with it and a non-absolute value associated with it. So here's the integral x plus absolute value minus x plus 2 absolute value dx between negative 2 and positive 3. Okay. Uh, Shout out goes out to Sadia for this problem, and she brought it to our attention. Okay, so well, with regard to these types of problems, if we were just handling x's, it wouldn't make a difference. We would just go follow through with the integral in the normal way. But when we have the absolute value, we have to be careful because now we have to consider only the positive values of this function. And but the x here, whether it has positive or negative, will net out positive or negative, but both will take care of each other as a typical integral. But this absolute value thing here presents a problem. We're only going to have positive values out of the entire function here. So basically, when we look at this, we can break this integral up, and now we're going to have minus 2 plus 3 of x dx. One of our laws of integrals is we could break it up into two separate integrals, and then we're going to have plus minus 2 plus 3 limits of the absolute value of minus x plus 2 absolute value, and there's your dx. Okay, let's take a look at these functions and see what they look like. Okay, so the first function I'm going to look at is I'm going to look at this. Let's see. I guess I'll look at this guy here, the x. Okay, I'm going to look at that guy and see what he looks like. Okay, so when I draw my xy plane, okay, plus x plus y, okay, I'm going to see that this y equals x function is just going to strictly come right through the 0, and there it is, y equals x. All right, so when I come backwards and I go from 1 2 and I go 1 2 3, say, I'm looking at this area here, okay, and this area here. So there's two areas going to be encountered, but as you know, we're out 3 in the positive area. We're only out negative to negative 2 here, so we're out 2 in this direction. So I'm assuming that this integral here is going to give us some positive value, but I got to let you know that there is some negative value here. So this is going to be a negative area, and this is going to be a positive area. Okay, so now we're going to look at the other part of this integral, and that's this guy. And when we do, we're going to see that this is a shift function, okay? He shifted over plus a minus 2, so it shifted to the right, okay? So when you go and we look at how you shift functions, you'll see that this guy, absolute value, is going to be shifted to the right. Okay, so what does that look like? 1 2, and we're going to go back here. Well, we're going to go over to 3, and then we go 1 2 backwards. Okay, so the function here is going to be like this: y equals plus x minus 2. Okay, and then he's going to take off and he's going to go this way, and that is going to be y equals minus x, okay, plus 2. This is minus 2 plus 2. Minus x plus 2, y equals plus x minus 2. So there's your absolute value function that we're seeing here. Now, upon further inspection, we're seeing that the area that we're going to look at is going to be basically here. We're going back to 2, so we're going to have all this area here, minus 2 plus 3, and this point is a critical point to be considered with, so we're going to do plus 2. So I'm saying that we have to consider this function changes. Okay, this is an entirely different function than this function. Okay, it's not smooth and continuous. It kind of stops abruptly here and takes off again. So therefore, we have to break this integral up into two integrals. So this one here is outside of the absolute value sign. It gets handled as a normal integral. So we're just going to leave that guy here, minus 2 plus 3 x dx. But this guy, we're going to change his limits, and we're going to put in these functions instead, okay, which you would see this here would be from negative 2, okay, over to positive 2 of this function, which would be minus x plus 2 dx. And then finally, we would do this other integral from 2 to 3 of x minus 2, x minus 2 dx. Okay, so there you go. We're breaking this integral up, and so we're going to get this. It's going to give us positive, okay, and then here we're going to get positive area as well. Okay, so very important. This is not one function. This is actually two functions because of the way this guy is set up. All right, with the absolute value. Okay, so now we're going to run along and do the integration. So we would here we would get x squared over 2 between negative 2 and plus 3, and then here we would get minus x squared over 2 plus 2x between negative 2 and positive 2, and here we would get x squared over 2 minus 2x between 2 and 3. And here we're going to run these numbers in here. So we would have the upper limit, which would be 3 squared over 2 minus 2 squared, minus and minus 2 squared, okay, over 2. All right, plus, now we have this one here would give us minus 2 squared over 2 plus 2 times 2, and then that would be minus this guy here, which would be a minus 2 squared over 2 plus 2 times minus 2. There you go. And then finally over here we get plus a 3 squared over 2 minus 2 times 3, and then minus all of this stuff here, which would be 2 squared over 2 minus 2 times 2. Okay, and let me run the numbers to the next line. Here we're getting 9 over 2, okay, minus 4 over 2. All right, plus, all right, over here I have negative 4 over 2 plus 2, plus 4, and Now I have a minus all of this stuff here, which would be 4 over 2. So a minus 4 over 2 minus 4, okay? And then here I'd have plus 9 over 2, okay, minus 6. And then minus all this stuff, which would be 4 over 2, okay, minus 4. And the next line, this would be 5 halves, okay? And over here I'd have minus, plus a minus 2 plus 4. And this inside of here, I'd have, what would I have here? I'd have 8 over 2 minus 8 over 2 minus 10 over 2, but it becomes plus 10 over 2, okay, because of this sign here. And then I have plus 9 over 2 minus 12 over 2. And then we have a minus 2 and minus 2 minus 2 over minus 4 rather, and let's bring it down again, 5 halves, okay. I'm trying to keep everything, so we're looking at this guy here. This first unit here is related to the first part of this integral. This second part is the second part. So here's all the numbers that are falling out of there. Here's the numbers falling out of there. And then this is the numbers falling out of here. And here's the numbers falling out of here, okay? And also, these numbers are the numbers that are coming from the first part of the integral, okay? So you're seeing that this is a negative part of the integral. You see here? You're getting some negative area added to the positive area, and it nets out as a 5 halves. And we were expecting that to be the case. It would net out as a positive 5 halves. Okay, let's see what we have here. So we have negative 2 and 4 is plus 2 plus 5. Okay, and then over here plus, let's see what we have, 9 halves. Okay, this becomes a minus 2 but a positive 2, so we have 9 halves minus 6 minus plus 2. So that plus 2 is really goes, if we're going to make these all 2's and add them all together, we're going to get 9 halves minus 12 halves plus 4 halves, okay, from the 2. And so this is going to become 13. So it's 13 halves minus 12 halves is 1 half, okay, and this is going to be 7. And so we have 5 halves plus 7 plus 1. So 6 halves. I think I'm making a mistake here somewhere. 6 halves is 3 plus 7 would be 10. And I must have made a mistake in the addition here in the middle. So I'm getting 10. But the answer is 11. So I probably messed up my math in the middle here. And I don't want to go hunting through it. But my point is with regard to this integral, the x is outside of the absolute value. So therefore, you're going to get positive and negative, and it's going to net out. As you see, you're getting a number that is going to be either positive or negative, depending on which one of these areas is going to be the greatest. Okay, but in this case, with this function, you had to break this function up into 2 different functions, and you had to realize where it actually comes to a point where we have the 2 separate functions are separated, and treat each individually and run down the areas. And let me just see if I could find my mistake here. So it's minus 2, the upper, right, minus what? The lower, okay? And so I have negative 4 over 2, okay, plus 4, That's right. So that's -2 plus 4 is 2. Correct. That goes right. So let's see this one. So this is 4 over 2 is -2. Okay. So this is a -2, and that's a -4. Okay. So that's -6 becomes -6 becomes +6. So it's plus 12 over 2, and that's where I came up. So I got the 6 here, and then that becomes 8. Okay, 8. And then this is 3. 8 plus 3, okay, when you add all these together is 11. So there's my answer. I knew it was 11 ahead of time, but now you see it. Okay, that concludes this video. Hope you liked it. Thank you.